Okay, boys and girls. Well, I hope we've been doing lots of review. We had some difficulty last week with some basic concepts that we should have had down. We'll spend a little bit of time tomorrow going over your take-home test. It was kind of a mixture of, I think we were searching on the internet for answers. It was good that we didn't directly copy, but there were things that were included in answers that we hadn't studied at all, and other things that should have been included in answers that were completely forgotten. Only one, maybe two students got the actual mathematical calculation question, which wasn't supposed to be that difficult. Again, some of you were searching the internet trying to find some sort of answer, but everything you needed to do was in your notes or in the question. Really, that was just a dimensional analysis question. So if you could do stoichiometry, there was no reason why you shouldn't have been able to do that question. So we'll spend a little bit of time on that tomorrow. What we do need to go through with tomorrow that we're going to finish talking about, and also going to go over today, is with our solubility curves and how to read a solubility curve. So you do have a homework sheet about that. So I'm not going to go directly over the actual questions, but I will go over very similar kinds of questions that you have in your homework sheet. So we can go over it. Okay, so number one, what are the customary units of solubility on solubility curves? So what kind of units do we see? Well, even if I didn't know, I could go down to my actual solubility curves. I've got curves for many different compounds here. I can see that number one on the bottom here, degrees Celsius, so it's in temperature. And then the other one is grams of solute per 100 grams of H2O, of water. I suppose you could have different solubility curves if you change the solvent as well. Okay. Number two, define solubility. So what does solubility mean? Well, solubility is a measurement of how much solute can dissolve. Okay, how much solute can dissolve, that's in grams, in a given amount of solvent, which is usually 100 grams of the solvent, at a given temperature. Okay, because as we see, we'll look at this, the solubility of many things changes, so how many grams will dissolve will change at different temperatures. That's why it's a curve. They're not straight lines. Some of them are more straight than others. Most of them are kind of a curve, or some of these might be just lines of best fit that kind of fit in there. Number three, according to the graph, the solubility of any substance changes as what changes? So the solubility, how much solvent will change according to what the temperature is. So as the temperature increases or decreases, the amount of solvent will change, or the solubility will change. How much solute will actually dissolve will change. And you've experienced this many times before, right? When you've maybe made some noodles. If you try to add that package of flavoring to cold water when you're making your noodles, it simply will not dissolve. But it dissolves quite easily once you heat it up, heat that water up to boiling. So that's the way most of these things work, although some of you may have noticed that, but there's some that show an opposite trend, which we'll get into here in a minute. For example, something like NH3, which is ammonia, which is usually a gas, you'll notice that actually as the temperature increases, the solubility of the gas decreases. And as likewise, as the temperature decreases, the solubility increases in a way. It's a very important skill in science to be able to read a graph and to see what's happening, what it means. 4, list the substances whose solubility decreases as temperature increases. Well, that's just what we looked at here. So this one is temperature in, let's make sure, solubility as temperature increases, yeah. So for ammonia here, NH3, as temperature's getting higher and higher and higher, the solubility is decreasing, 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 decreasing. Okay? Is there another one on this graph that shows a similar trend? Well, this looks like it's increasing, this increases, increases, increases. This one, cesium sulfate, I think is what that one is. That one shows a very rough trend, but also downward trend of decreasing solubility with increasing temperature as well. This is a weird one, and I'm not exactly sure, and I'd be interested to look this up. Why? Because I'm guessing this is a salt, and it's a solid, so it should, most solids that you dissolve, their solubility increases, right, with increasing temperature. It's gases that show the opposite trend. Okay. Number 5, which substance is least affected by temperature changes? Least affected. So if we're looking at this graph and we want to know which one is the least affected, then, just like in math class where you're kind of looking for the slope, the rise over the run of certain things, ones with a steeper line, a larger slope, are going to be more affected by, say, temperature changes here. Like, look at this one, potassium nitrate look at how steep that line is. That's hugely affected by temperature changes. It really increases very rapidly at a high rate. But if we want one that's least affected, then we probably want to look for something that looks more like a straight line, or one with the least amount of slope possible. And none of them really have a straight line too much, but if you look at here, sodium chloride, NaCl, your table salt, it pretty much it's pretty close to having a straight line. It has a small slope to it. So that one shows you it's kind of least affected by kind of increasing temperatures. And in some ways you know that too. It's very easy in a way to get salt to dissolve in water. Getting hot water doesn't really increase the ability for it to dissolve. A little bit, but not too much. 6, how many grams of ammonia chloride, NH4Cl, will dissolve at 50 degrees Celsius? So this says, can you read a graph? So ammonium chloride, where's that? Well, that's this line here. It's ammonium chloride, and at 50 degrees Celsius. So all I need to do is just go down here from lines 50 degrees, read up, so it looks like it's 50 grams. 50 grams, okay, that shouldn't be too bad. Blank and blank have the same solubility at 78 degrees Celsius. Which two things have the same solubility at 78? So this, I'm going to look kind of around 80 and see, are there two lines that are fairly kind of close together? These two lines intersect right here. So what's this? KCl3, that's potassium chlorate. I hope you know these names. Potassium chlorate and sodium chloride. They both kind of intersect around 78 degrees. And they both have roughly about 30, maybe about 39 grams at 78 degrees Celsius. Which compound is the least soluble in water at 10 degrees Celsius? So we're going to look at 10 degrees, which is the least soluble, so it's going to have the least amount of grams that are going to dissolve. So that's easy. We just go to the first one right here. And so this is potassium chlorate. It only has at 10 degrees Celsius, it only has about maybe 5 or 6 or so grams per 100 grams of water. 9. How many grams of KNO3? What is that? That's potassium nitrate. can be dissolved at 50 degrees Celsius. So potassium nitrate, here's our line, 50 degrees Celsius, looks about 80 grams. Okay. Are the following solutions unsaturated, saturated, or supersaturated? So if it's unsaturated, meaning that at 30 degrees Celsius, you could still dissolve more sodium nitrate into the water. Like 45, you can still put more in after 45 at this temperature if it's unsaturated. If it's saturated, you can only put in 45. Nothing, no more will be allowed in. And if it's supersaturated, then it's above the line, meaning that the water is actually holding more of it at that given temperature. So we've got sodium nitrate, 30 degrees Celsius. Sodium nitrate, so 30 is down here, and it's saying so what did we have? 45 grams of it. So 45 grams. So it looks like at 30 degrees Celsius, it should hold about 96 grams. Let's make sure I got that right. Are they unset? 45 grams at 30 degrees Celsius. 30 degrees Celsius, 45. So here's the line here, 30 grams. So if I only have 45 grams, it's way below the line. So that means that at this degrees temperature, it can still dissolve a lot more. So that's unsaturated at that temperature. 60 grams of potassium chlorate. Here it is. 60 grams. What was that? 60 degrees Celsius. Potassium chlorate, so it looks like that can hold about 25 grams at that temperature, but it says 60 grams, so that one would have to be, it'll be way above the line, so that would be supersaturated. How many grams of sodium chloride, NaCl, are required to saturate 100 grams of water at 100 degrees Celsius? So we want to saturate it, so it's going to be right on the line. So NaCl, it's going to be right here. So it looks like it's approximately right at 40 grams. If you want to be saturated, it needs to be right on the line. Less than the line, it's going to be unsaturated because it can hold more, and then still more, but supersaturated, those conditions where it's got more than what it should be able to hold. How many grams of sodium nitrate are required to saturate 100 grams of water at 90 degrees Celsius? Sodium nitrate, 90 degrees Celsius. How many? Woof, this is going way up. Ooh, in this one we have to make a guess because it's right off our chart. So our highest amount here is 150. If this line were to continue, it looks like it would continue about here or so. It could be around 100. Let's just make sure I'm reading it right. 90. It's funny because that answer that they, let's make sure that I've got this right. Yeah, sodium nitrate at 100 degrees Celsius. At 100 degrees Celsius. So that's going to be considerably above the curve. It could be like 160 or something like that. 90. So that, yeah, it looks like 160 or something. So how many grams of, what's this? Potassium iodide will saturate the water at 20 degrees Celsius. So we got 20 degrees Celsius, and potassium iodide is here, 20 degrees Celsius. That looks like about 33, 34 grams. At what temperature would 25 grams of potassium chlorate dissolve? So we're going to go potassium chlorate. Where's potassium chlorate? Here. We want 25 grams. So 25 grams about here. So maybe about, yeah, maybe a little bit below 60 degrees. So maybe like 57, 58 degrees Celsius, something in there. At what temperature would 55 grams of ammonium chloride dissolve? 55 grams, 55 grams, maybe there. That looks like about 60 or so. Let's put 55 grams. That looks like that's about 60. 16. If 89 grams of NaNO3 is prepared at 30 degrees Celsius, will all the salt dissolve? So we got 30 degrees Celsius, 89 grams Na. Sorry, what's that again? 30 degrees Celsius, 89 grams. Will 30 degrees Celsius, 89 grams? Yeah, it should. Yeah, 89 grams is prepared. Will all the salt dissolve? So here's our line. 30 degrees Celsius brings us up here. That's over 90 degrees. Oh, wait a minute. 30 degrees. It's over 90 grams. So should it? Yes, it should. What mass of will dissolve? Looks like about 95 grams or so will dissolve. Okay. If 25 grams is dissolved at 50, how many additional grams of NH4 would be needed to saturate the solution at 80 degrees Celsius? So at 80 degrees Celsius, it will hold about 65 grams. And what did it say? We had how many grams? We had 25 grams. So that's just a nice subtraction problem. So that's about 40 grams or so. I think. Fifty grams, we had 25 grams. Yeah, there's still a lot there that can still dissolve. Yeah, I think that's about right. 18 at 50 degrees Celsius, how many grams of potassium nitrate will dissolve? 50 degrees, how many? Looks like 80 grams. At 70 degrees Celsius, how many of cesium will dissolve? 70 cesium, oof, that looks maybe 5 grams or so. Okay, determine if it's unsaturated, saturated, or supersaturated. So 55 grams NH3 at 20. So here's 20 NH3, 55 grams. I'm going to... does that say 55 grams? It does say 55 grams. it looks like that's either right at 55 grams or a bit below. So I'd say maybe you're good with saying it's like saturated. 10 grams of cesium at 10 degrees, 10 grams at 10 degrees. So we've got 10 grams, 10 grams, so it can still hold more. So that one is unsaturated. 125 KNO3 at 60 KNO3. So at 60 KNO3 will hold around 100. And what did we have? 125. If you're getting 125 in there, that's going to be over the amount. So that'll be supersaturated. 65 grams NH4Cl at 80 NH4Cl. 80 will hold about 65. That looks saturated right on the nose. 12 grams of NH3 at 90. 12 grams, that looks like that one would be over, because that looks like that it will hold about 10 grams. That'd be slightly over. That'll be supersaturated. 80 grams of sodium nitrate at 10 degrees. Sodium nitrate, 10 degrees, 80 grams is right on the nose. That's saturated. 145 of sodium nitrate at 80. 80 sodium nitrate at 80 is way up here. That'll hold about 145 or so. Yeah, that one's saturated too. 35 grams of NaCl at 100. 135. So 35 is down here, so that looks like it would be unsaturated. It could still hold a few more grams of salt at that temperature. Okay, please watch the video, practice the vocabulary, come to class with questions, be prepared to do your work. Thank you. Have a nice day.